Hey, how's it going, everybody? Alright, what we're going to be doing in this video is we're going to be continuing to use the unit circle, but in particular, we're going to focus on this. We're going to learn the relationships between angles that have either equivalent sine, cosine, or tangent values. Alright, so if I told you that the sine of 70 degrees equals some number, I'd want you to be able to figure out what are other angles that had the same sine value as the sine of 70 degrees, or the same cosine value as the cosine of 70 degrees, or that kind of thing. All right, very specific relationships. Now, this is hardly going to be an exhaustible list, but it's a very good list for you. And it's something that you're just going to have to kind of put in the back of your head, because when we start solving trigonometric equations, which is coming up in the next section, you're going to need to know these things. All right, that'll all make sense to you as we get to it. Now, the first thing I want to talk about in terms of angles that would have the same sine or cosine or tangent values is what are called coterminal angles. And I used this term in the previous video that we were watching, but it wasn't a focus, and so now I want to make it a focus. When I'm talking about two angles that are coterminal angles, I'm talking about angles that have the exact same terminal side. All right, so for instance, let's suppose that we put the angle 300 degrees in standard position. Here's the terminal side of that angle. All right, remember, the initial side of an angle is always the positive x-axis, and then this time we went counterclockwise 300 degrees. Here's where we ended up. You know that that angle would be coterminal, or have the same terminal side as negative 60 degrees. Now, that's an example in degrees. Let me give you an example in radians as well. Suppose we had the angle 5 pi over 4. Well, that would be coterminal with this angle, negative 3 pi over 4. Now, we need some logic to kind of figure out the relationship between the measures of two angles that are coterminal. All right, and here's what it is. Let's say that I wanted to find a third angle that was coterminal with either 300 degrees or negative 60 degrees. Well, it's got to finish in the exact same spot. And so what I got to figure out is how many degrees apart are two angles that are coterminal. And it turns out you'd have to go around the circle one time entirely to get back to the same point, wouldn't you? So if you say take negative 60 degrees and you go counterclockwise around the circle one time, that gets you to 300 degrees. And when you go around the circle one time, you've gone 360 degrees, haven't you? So you can add 360 degrees to an angle in order to find out another angle measure that's coterminal with that. Or conversely, you could subtract 360 degrees, meaning that you could go clockwise one revolution around the circle in order to find an angle that is coterminal with a given angle. All right, now that's if we're dealing with degrees. Now let's suppose that we had two angles alpha and beta that were coterminal with one another. How would you find alpha if you're given beta? Well, you can simply do this. You can take the angle alpha or the angle beta that you're given, and you can add 360 degrees to it in order to find a coterminal angle, right? Because we said if we start here and we go 360 degrees in the counterclockwise direction, we end up with a coterminal angle. Now, we also said that if you start at an angle, you can go 360 degrees clockwise or in the negative direction to find an angle that's coterminal. So you can say it's actually, you can either add or subtract 360 degrees to find a coterminal angle if you're working with degrees. Now, you can actually add or subtract any multiple of 360. You could add 720 degrees, add 1080 degrees, or subtract those amounts to find coterminal angles, because for every 360 degrees that you go around the circle, you end up with an angle that's coterminal to the one that you started with. And then if you're thinking about the same kind of concept but in radians, well, when I add 5 pi over 4 and negative 3 pi over 4, the way I get from one to the other, say I started at 5 pi over 4, is I had to go clockwise around the circle one revolution. And when we're talking about radians, going around the circle one time means going 2 pi radians. Or if we had started at negative 3 pi over 4 and gone 2 pi radians in the positive direction, counterclockwise direction, that would have gotten us to 5 pi over 4. So you can take any angle measure in radians and you can either add or subtract 2 pi and get an angle that's coterminal with it. Or you can add and subtract any multiple of 2 pi, either 4 pi, 6 pi, 24 pi, whatever. Alright. Now, one other thing to note with that is that whenever two angles are coterminal, their sines and cosines and tangents have to be the same because, so for instance, negative 60 degrees and 300 degrees have equivalent x and y coordinates, don't they? So their sines and cosines and tangents are equivalent to one another. And that's one of the things that we care about in this video, is trying to find out when two angles have equal sines, cosines, or tangent values. Now, let's go ahead and do this example really quick and move on to some other relationships I want you to learn. I want us to find one positive angle and one negative angle that is coterminal with a given angle. And I'd like us to use the same units that the angle was given in. So these two angles here, I've given to you in degrees. We're going to give our answers in degrees. All right, and very simply, here's the way that we're going to do that. Let's take that 130 degree angle. If I wanted to find another positive angle that is coterminal with that, all I need to do is take 130 degrees and add 360 degrees to it. And so 490 degrees would be coterminal with that, right? That's going one revolution around counterclockwise in the positive direction. Or I can take that 130 degrees and I can subtract 360 degrees from it, which is negative 230 degrees. Those two angles here and there are going to be coterminal with 130 degrees. Now, do the same thing here with the negative 280. If I want to find a positive angle that's coterminal with negative 280, let me just add 360 to it. All right, and that means that the angle positive 80 degrees would be coterminal with negative 280. And if I wanted to find another negative angle measure that's coterminal with negative 280, all I have to do is subtract 360 from it. Negative 640 degrees would be coterminal. All right. Now, sometimes you might have to add 360 twice to go from a negative angle to a positive angle. You know, for instance, if I had the angle negative 500 degrees and I wanted to find other angles that are coterminal with that, well, if I added 360 once, that would give me a negative angle that's coterminal with negative 500, and then I'd have to add 360 degrees again to finally get a positive angle that's coterminal with that, right? Okay, so just use your common sense, make sure you get two angles that are coterminal with the same angle if you're asked to do such a thing. Now let's do the same thing but with radians, and really here I'm showing you this still because we need to learn to keep exact values while adding and subtracting pi or 2 pi or that kind of thing with radian measures. You'll see what I mean in a second. Alright, if I want to find another positive angle that's coterminal with pi over 5, but in radians, well, we said you add 2 pi radians, don't you? Alright, and so now, in order to add pi over 5 with 2 pi, we've got to be able to have two fractions that have the same denominator. So let's say we make this pi over 5 and 10 pi over 5. Right, give them the same denominator and then add. So 11 pi over 5 would be an angle that's coterminal with pi over 5. Then I can subtract 2 pi and get the same, and get a negative angle that's coterminal with that. All right, so negative 9 pi over 5 would be a negative angle coterminal with the original angle. Those are our two answers right there in radians. Now, I'm not going to verbalize how we do the same thing with negative 5 pi over 12 because I'm trying to save time on this video. It's going to be kind of lengthy. But I am going to write the work out right now, and you can kind of figure it out on your own and then just check, or just write this down and check later. That's fine as well. And then you'll find that 19 pi over 12 and negative 29 pi over 12 are coterminal with negative 5 pi over 12. All right, great. So that's coterminal angles. Now I want to look at another relationship between two angles that have equivalent sine values. All right, and this again is just another way of finding an angle that has the same sine value as a given angle. Now we've actually already learned this back in the previous chapter. Remember that the sines of supplementary angles are always equal to one another. For instance, if we take the two angles 20 degrees and 160 degrees, they have the same y-coordinate, don't they? Because they end up being reflections in the y-axis, and so their sine values are equal to one another. All right, supplementary angles have equivalent sine values. Now that works in a non-traditional sense as well. Let me draw another pair of angles here. I'm going to erase those. Let's say that I had an angle negative 100 degrees, and I wanted to find out which angle in the fourth quadrant would have the same sine value. Well, I just have to pick an angle that when I add it with negative 100 would give me positive 180 degrees, and that turns out to be 280 degrees. Okay, those do have the same y-coordinate, don't they? And they add up to 180 degrees, so they're going to be equal. Their sines are going to be equal to one another. Now I'm going to generalize this a little bit more. Let's say that this angle is just alpha, and I wanted to find out what you can add with alpha to get 180 degrees. Well, if I wanted to find the supplement, say, of 70 degrees, wouldn't I subtract that from 180? And that's always the case. If you want to find the supplement of an angle, even in a non-traditional sense, all you have to do is subtract that angle from 180 degrees. So this angle over here would be 180 degrees minus alpha. And that's how, using degrees, you can tell if two angles had the same sine value, if they add up to 180 degrees. So if alpha, well, let me phrase it the way I've got it on the picture. Let's say if beta is equal to 180 degrees minus alpha, then those angles are going to have the same sine value. And then let's make the equivalent statement using radians. Just substitute pi instead of 180. If two angles add up to pi radians, that means they're supplementary to one another. And so if beta equals pi minus alpha, then the sine of alpha would equal the sine of beta. Now let's put that into practice a little bit. Let's say I wanted to find three other angles with the same sine as negative 25 degrees. All right. Well, here's what I'm going to do first. I'm going to find out what is 180 minus negative 25, because that angle will have the same sine value. And that's equal to 205 degrees. Now let me just reinforce that with a picture. There's where negative 25 degrees is. And here's 180 plus 25. There's 205 degrees. They have the same y-coordinate, don't they? So just subtracting the angle from 180 gave you another angle that had the same sine value. Now how about two more angles with the same sine value? Well, how about we take advantage of the fact that coterminal angles have equal sine values? Let's find, and I'd prefer to keep these angles between negative 360 and positive 360. Let's find the angle between negative 360 and positive 360 that's coterminal with negative 25. I can find that by adding 360 degrees, couldn't I? If I add 360 to that, I get 335 degrees. And again, trying to keep this between negative 360 and positive 360, if I want to find a coterminal angle with 205, I'm going to have to subtract 360 degrees. And that would give me negative 155. There you go. That's three angles with the same sine value as negative 25 degrees. Now let's do the same thing, but with radians. All right, with radians, of course, we're going to subtract the given angle from pi to find out what its supplement is. And if you do pi minus 3 pi over 7, you're going to get 4 pi over 7. Right. 7 pi over 7 minus 3 pi over 7 is 4 pi over 7. Now I'm going to back this up with a picture as well. 3 over 7 is a little bit less than 1/2, isn't it? So there's 3 pi over 7, just shy of pi over 2. And then here is 4 pi over 7. They clearly have the same sine value, don't they? All right, and then for two other angles that are they have the same sine value, I want to find angles that are coterminal with each of these. And I would like to keep the angles between negative 2 pi and positive 2 pi. Not that I have to. Really, I can just either add or subtract 2 pi from either one of these things. But since these are both positive, I'm going to subtract 2 pi and get negative angles that have the same sign values. 3 pi over 7 minus 14 pi over 7 would be negative 11 pi over 7. And then 4 pi over 7 minus 14 pi over 7 would be negative 10 pi over 7. Those angles would all have the same sign value. Now how about angles with the equivalent cosine values? Alright, so if two angles have the equivalent sine values whenever they add up to 180 degrees, how do you know if they have the same cosine values? Well, let me draw you a picture of a couple of angles that would have the same x-coordinates, alright, because that would mean they have the same cosine values, right? Let's just say this angle and this angle. And then let me give you an example of the angle measures that could possibly accompany that. Let's say that this is 30 degrees. Well, the angle that would have the same x-coordinates that would either be negative 30 degrees or 330 degrees. Alright, and I want to go with the 330 degrees there because I want to show you the sum of two angles that have equivalent cosine values is going to be 360 degrees. You notice how 30 and 330 adds up to 360. Now let me give you another example. Alright, you can see that 135 degrees and 225 degrees also have the same x-coordinates. They're reflections in the x-axis of one another. And 135 plus 225 is 360. Alright, so two angles, alpha and beta, would have the same cosine value if alpha plus beta equals 360, or the way that I want to write it is that two angles will have the same cosine value if alpha is equal to 360 degrees minus beta. Alright, to find another angle that has the same cosine value as any given angle measure that you want, just subtract the angle that you have from 360. Now that's of course if you're dealing with degrees, and then in radians the equivalent value to 360 is 2 pi. So we can say that any two angles adding up to 2 pi are always going to have the same cosine value. And we could say that to find an angle that has the same cosine value as something, you subtract that angle from 2 pi. Alright, so there you go. Just a quick example of that here. If instead of degrees I give radian measures to the same two angles I was looking at right here and right there, 3 pi over 4 and 5 pi over 4 do add up to 8 pi over 4, which is 2 pi, right? Okay, so that's how you know if two angles have equivalent cosine values. Now here, what I'm asking you to do is similar to what I asked you to do with sine values. I want you to find 3 other angles with the same cosine as the given angle. Alright? Now we're only going to find one other angle that adds up to 360 degrees with this, but that is one of the answers that I'm going for. So let's do 360 minus 105. And so that'll tell us that 255 degrees would have the same cosine value as 105 degrees. Alright, and then all we're going to do is find coterminal angles. One angle that's coterminal with 105 and one angle that's coterminal with 255. Since those are both positive, I'm going to prefer to find a negative angle that has this coterminal with each of these. So I'm going to subtract 360 from each. We could do 105 minus 360. And that's going to be negative 255. Okay, now this is another observation you can make, is that angles with opposite degrees or radian measures are always going to have the same cosine value. And then if I do 255 minus 360 to find its coterminal angle, I'm going to get negative 105. Alright, so that's a little bit easier to find the equivalent negative cosine values to go along with a positive cosine value actually than it was whenever we were trying to find sine values anyway. This is more of a pattern. Alright, now this next angle is in radians, and so we want to subtract it from 2 pi to find the angle that would have the same cosine value. So 2 pi minus negative pi over 6. Alright, well that would be equivalent to 12 pi over 6 plus pi over 6, so 13 pi over 6. Alright, now we're going to find a coterminal angle with each one of those, and I'm going to relax my kind of rule on having one positive one negative angle that's coterminal. I think you'll see why here in a second. Hold up. Alright, so I want to subtract or add 2 pi with negative pi over 6. That's a negative angle. I'm going to try to get a positive angle with the same cosine value, so I can make that this. All right, there's me adding 2 pi to the angle measure to get a coterminal angle. Then I'm going to try to find a smaller angle that's coterminal with 13 pi over 6. If I subtract 2 pi from that, I'm still going to end up with a positive angle, and that's fine. Alright, so pi over 6 is going to be coterminal with that. These three angles at the end of the equations are all going to have the same cosine values. Alright, excellent. Now let's talk about how you know whether two angles have equivalent tangent values. And it turns out that angles that have equivalent tangent values are at opposite ends of the same diameter on a unit circle. So let me give you a couple of examples here, starting with 150 degrees and 330 degrees. Now let me show you the sine and cosine of each, well, how you calculate the tangent basically of each. And you see that the sine of 150 degrees is positive 1/2, its cosine is negative square root of 3 over 2. And then for now, I'm just going to simplify that then to negative 1 over the square root of 3. The denominators in each of those fractions cancel one another out. And all I care about is whether the tangent of 330 is equivalent to that. That's why I don't care about rationalizing that denominator. And then let me show you the tangent of 330 degrees. Again, doing sine over cosine to calculate that. The sine of 330 is going to be negative 1/2. The cosine of 330 is going to be positive square root of 3 over 2. And that as well will simplify to negative 1 over the square root of 3. Now probably one example is actually enough for me to convince you here. Angles at opposite ends of the diameter of a unit circle have the same tangent values. Now, how many degrees apart are those angles going to be? Well, if they're each halfway around the circle from one another, that means they're going to be 180 degrees or pi radians apart. So, two angles, alpha and beta, would have equivalent tangent values if they are 180 degrees apart. And that means that you can always add 180 degrees to beta to find out an angle that has an equivalent tangent value. Now I'm going to put a little plus or minus in there because you could actually also subtract 180 degrees from any angle to find another angle that has an equivalent tangent value. And then we could do the equivalent thing in radians, which is that you could either add or subtract pi from an angle in order to find another angle with the same tangent value. Alright, so same basic questions we've been asked with the sines and cosines. Let's find three other angles with the same, actually I asked the exact same question. I'm going to change that to tangent. Three other angles with the same tangent as a given angle. And I'll do what I just told you, where I'm just going to add 180 degrees to that angle first. And let's say then at 360 degrees has the same tangent value as 126 degrees. And then I'll go ahead and do what I've been doing, where I'll take these two angles and find a coterminal angle. I'm going to subtract 360 from each of them. 126 minus 360 and 306 minus 360 give you negative 234 degrees and negative 54 degrees respectively. Alright, and then for 2 pi over 5, since that's in radians, we're going to either add or subtract pi from that angle to find an angle with the same tangent value. Alright, so there's me adding pi. 5 pi over 5 is really pi. With 2 pi over 5, you get 7 pi over 5. Then we'll find the coterminal angles for each of these two things right here. By subtracting 2 pi, we'll go for the negative angle measures. Now, if I'm subtracting 2 pi here and I want to get the common denominator, I'm really going to subtract 10 pi over 5 from each angle. That is 2 pi. And you get negative 8 pi over 5 and negative 3 pi over 5. Alright, then just to illustrate the point, here's 2/5 pi. It'd be a little bit less than a half pi, wouldn't it? So right there. And then here's 1 and 2/5 pi, or 7 pi over 5, a little bit less than 1.5 pi. And you can see those are at opposite ends of the diameter, so they would have the same tangent value. Then, if I move 3/5 pi in the clockwise direction, that's going to be a little bit past 1/2 pi, negative, in the clockwise direction. And if I go 1 and 3/5 pi in the clockwise direction, that'll be a little bit past 1.5 pi, right? And those again are opposite ends of the diameter, so they have the same tangent value. Alright, one more set of examples, guys, and we'll be done with this. Given that the sine of an angle theta is 5/13 and the cosine of an angle theta is 12/13, I want us to find several values here. Okay? And the reason why I want us to practice this is it has things like 360 minus theta or pi minus theta, and you might think, well, I don't know what theta is, so how am I going to find out what 360 minus theta is, and so forth. But I'll talk you through how you do it. It's using one of the skills we've learned in this video, basically. Now, the first one's easy enough. If you know the sine and the cosine of an angle, you just divide those in order to find out what the tangent of that angle is. So we're going to do 5/13 divided by 12/13. Since the denominators are the same in those fractions, they'll just cancel out, and we'll get 5/12. Okay? Then for the cosine of 360 minus theta. Well, the cosine of 360 minus theta is going to find the angle that you would combine with whatever theta is to add up to 360. Cosines of angles are the same if they add up to 360. So, if the cosine of theta is 12/13, the cosine of 360 minus theta is also 12/13. Not that difficult, right? Okay, now when we're talking about sines, remember sines have the same value if they add up to 180 or if they add up to pi radians, which we're doing with radians here. So if I do pi minus an angle, I'm finding out what you would add to that angle in order to make it have a total of pi radians. It's going to have the same sine value as theta itself, right? These are supplementary angles that I'm dealing with. So the sine of pi minus theta is going to be 5/13. Okay, now how about a couple other variations? For these two where I've just got the opposite of an angle, I'm going to need to show you a picture of that. The sine of the opposite of an angle theta, well, let's say that this is an angle theta right there, then the opposite of theta would be right there, and those are reflections of each other in the x-axis, aren't they? So they're going to have opposite sine values. And since the sine of theta is positive 5/13, then that means the sine of the opposite of theta would be negative 5/13. Alright, and then let's think about tangent. So if the tangent of theta is sine of theta over cosine theta, and then we're looking at the opposite of theta, well, the opposite of theta is going to have the opposite sine value, we said, of theta. But aren't the x-coordinates the same here? So it's going to have the equivalent cosine value, which basically means then that the tangent of the opposite of theta is just going to be the opposite of the tangent of theta, right? Okay, so we've already figured out that the tangent of theta was 5/12, so the tangent of its opposite angle would be negative 5/12. Now one more kind of tricky one, then one more easy one here. Alright, this time I'm asking you to find the cosine of pi minus theta, which means I'm asking you to find the cosine of the supplement of theta, right? If two angles add up to pi, then they're supplementary. Now, the sines of two angles are equal if they have the same, or if they're supplementary to one another. But you might remember the cosines of two angles are when the angles are supplementary, are opposites of one another. Let me give you a quick example here in a picture. Suppose theta was pi/4, then 4pi/4 minus pi/4 would give you 3pi/4, right? Supplementary angles are always reflections of one another in the y-axis, so they have opposite cosine values. So the cosine of pi minus theta would be the opposite of the cosine of theta, which then would be equal to negative 12/13. Alright, and then finally the tangent of 180 degrees plus theta. Well, we said every time you add 180 degrees to an angle, you get another angle that has the equivalent tangent value. So this would be equal to the tangent of theta, which we've already said was 5/12. Alright, there's a ton of information for you to process this in this video. You might have to go back and watch one or two parts, a couple times just to make sure that you've got it. But you ought to know the relationships between two angles that have the same sine value, the relationships between two angles that have the same cosine value, and the same tangent value as well. Alright, thanks for your attention, everybody. Hope this has been helpful. See ya.